I may have to do these in a few sessions, but I was hoping to do example problems for Module 9, acid-base chemistry, and then do the sample problems, and then do the practice problems, and then do the extra practice problems. But I keep getting interrupted. My toddler is now up from nap. So this is example 9.1. We are determining which reactant is the acid and which is the base. So they gave you the equation, and you just have to find which is an acid donor, which is your acid, and which is the hydrogen acceptor, which is your base. So it's kind of important to know whenever you have an ionic compound in water, it separates into its ionic components. So when you see the aqueous, it means it's in water, and more than likely it's going to follow into something like this. So if you see that this one over here has one less hydrogen, you are right. So this is our donor, this is our acid. And if you notice over here, there is a hydrogen there, right there. This is our base. That's simple. Okay, let's look at acid base in hydrochloric acid. And I do recommend on the next page, what page was that? I think it's a couple pages over, 324, there is a chart you should put on the back of your periodic table so you don't have to memorize it. Aqueous plus NaOH, NaOH, aqueous yields H2O plus NaCl. And if you remember right, this they didn't tell you this beforehand, but reacting an acid and a base creates a salt, at least a hydroxide. Okay, so which one is our donor? This one. Our hydroxides are always our bases because they always create water, and then these two become your salt over here. So acid base. Okay, let's go on to the next one. And I am going to clean my board. 2HNO3 plus magnesium oxide. And these are aqueous solutions. Yields magnesium, NaO3. No, please don't write on mine. No, that's not. You color on Minnie Mouse. 2 aqueous plus 2H2O liquid. Okay, so anytime you have a hydroxide, that is going to be your base, because that's going to come over here and become your water molecule. So this is going to be your acid because it's going to donate those two. So then your magnesium oxide will form your salt. This is your salt. Okay, our next one. Oh, I guess that's it. All right. There's our table. Okay. Let's do example 9.2. Give the balanced chemical equation that represents the reaction between HCl and RbOH. Okay, so here is our base. So we know we're going to have water and a salt, which is RbCl. Since OH is a negative, so we know that the Rb is also negative. We can also look in our periodic chart right here to see it right there, number 37. But we don't have to, because we can tell from how, as long as these are listed correctly. So there it is. So write a reaction described between sulfuric acid, H2SO4, plus NaOH, Okay, here's our base because it has hydroxide. We're obviously going to have water. Usually put the water at the end. NaSO4. So there's one of those. There's going to be two NAs because Na has a 1 charge. If you look at your periodic table, you'll see that. And there'll be 2 waters because we'll have 2 hydroxide ions from that. And yep, and you'll have to get rid of these 2 hydrogens. So that'll be balanced right there.
I just tried to.
Yeah, that's I see. Yeah, I see that. Okay. HNO3 plus aluminum hydroxide. Again, there's your base. It has to be a 3 because aluminum is a 3. And so if we are since this is a +1, or -1 actually, sorry, -1,
Yeah.
and this is a +1, we're going to have aluminum.
Yeah.
Shh. If you want them, go get them.
Uh-oh.
We're going to need 3 of those in order to make 3 here. Since aluminum is a +3, and this is obviously a -1. We have 3 of those, so we need 3 hydrogens. And aluminum has a +3, so we need 3 of these. This is a -1. Why did I say 2? So that is our balanced chemical equation. Whoops, I forgot my 3 here. Sorry. Because there's 3 of these right here. So since there's 3, we'll have 3 oxygens, and we'll need 3 of those. There's 3 of those. So 3 oxygens. Sorry, guys. Almost left that up. Okay, we'll go on to the next one. So that was example 9.2. Okay, so let's do 9.3. What reaction occurs H3PO4 and ammonium NH3, which is a base? So here's your acid, here's your base. So this one here is where they have the triprotic acid with a covalent base. So there's just 1 hydrogen transferred, they say. I'm not gonna lie, these are hard. Definitely hard. So we're going to move this 1 hydrogen to this one here so that it becomes, we'll need 3 of these because there's 3 hydrogens here, so that it becomes, so we'll end up having 3 NH4, and these are a positive. And you'll just have your PO4 hanging out there, which is a -3 because, because hydrogen's a +3. And then here with the H2CrO7. And it's going to be water. So our water in this case is actually going to be our base. We're going to have 2 of those because we have 2 hydrogens to get rid of. So we're going to have CrO7. This is obviously a -2. And then we're going to have 2 H3O, which I think I'd have to go back and look at my polyatomics. Let's look here. H3O. Or maybe that's our base. H3O. H3O must be a positive. Yeah. Because it would have 2 extra hydrogen. I would have 1 extra hydrogen atom. So it would obviously just be +1. I'm not gonna lie, those ones are hard. Okay, now we're gonna get a chance to start working with some classic stoichiometry. These next few problems, we're gonna start with kind of simple with molarity. What concentration in units of molarity is NaHOH if there was 2.6 moles with a volume of 534 milliliters. So 2.6 moles divided by 0.534, because that's liters, because it's moles per liter, and then that should give you your molarity. So you just take, whoops, my calculator cut off, 2.46 divided by 0.534, and that should be 4.86, repeating, let's see, equals 4.86891. And we only have 2 sig figs, so I'm going to say 4.9 moles. Oh, look at that. We're right. Okay, let's do the next one. A student dissolves, my coffee, 124.3 grams of HNO3 to make 250.0 milliliters. What is a molarity? Okay, so now we have grams. We need to get to grams to moles. If you remember, if you don't remember, hopefully you have it written on your periodic tables. There are the atomic mass units equals that many moles, if you remember right. So we need to find the atomic mass units of HNO3. So 3 times 16 plus, H is 1.01 plus, and I have to look it up, 14.01. Every so often I forget it. Do you need more? Here's the pencil. So we're going to take 3 times 16. Yeah, it's a pencil. So 3 times 16 plus 1.01, oops, not times, plus 14.01 equals 63.02. 63.02 AMUs, and 1 mole, if you remember right, 1 mole equals that many grams. So 1 mole equals that many atomic mass units. So now this is 6.30, wow, 63.02 moles. So we have our moles. That's how many moles. Oops, what am I doing? Okay, so 1 mole equals 6.30 grams. I just said that over here. HNO3. Okay, so we have this many grams though. So I need more space. We'll erase this up here. Running out. Okay, so we have 124.3 grams over 1 HNO3. And we are given that 63.02 grams HNO3 is 1 mole. Just got done saying that right here. So we can take out our grams there and we'll get moles. So we're just going to, so now we just multiply 124.3 divided by 63.02 equals 1.97 0.23 moles. Great. So that's where our next step is. So now we've got moles, and that is HNO3. HNO3. So now let's start over here. 1.972 mole HNO3. And really, we're going to have to go down to 3 because of 1, 2. Well, that's technically 4, so we should be okay with that because of this here. And 1, 2, 3, 4 moles over 1. And we're going to multiply that. Let's see here. Moles. We've got that there. We have that many moles. Now we need to actually just divide it. Sorry. We just need to divide it by this. 0.256 liters. That should give us the moles. And divide that by 0.256 equals 7.70 molarity HNO3. Let's see what the answer said. Well, 7.88. I think that they let's see here, 0.25. Did I do the right numbers? Oh, that's a 0. That's why. So let's try that again. So 1.972 divided by 0.250 equals 0.88. There we go. Sorry about that. My sloppy writing gets me into trouble. So this is our answer. Great. Okay, let's erase and do the next one. Okay, Kenneth wants to dilute 12 moles of HCl to make 500 milliliters of 3.5 molarity HCl. Okay, how would we do this? Now, there's a great equation. M2V2. Leave Mama's stuff alone, please, Azzy. Mama. Okay, so all we have to do is plug those in. That's really nice. So, if molarity is this, we got V2 here. Get off the table, please. 3.5 moles times 500 liters. All you have to do is divide by this 12.0. 12.0. I don't even think you need to put your moles in there. So we have 500. Sorry, try to put this over where you can see it. I don't think you can quite see the numbers though because of it's not super bright. So 500 times 3.5 equals, divide that by 12, and that there should be your molarity. Your 145.83, and that should be your milliliters. Since this is in milliliters, our answer should be milliliters. But since we only have 3 over here, it should be 146 milliliters. Let's see. They use 2. I don't see 2. Oh, no. Oh, they did this molarity. Okay. So yeah, you should just have 2, which is 150 milliliters. Yes, because of this one. This is our sig fig. I missed that one. That's our sig fig. So 150. Okay. You guys sit on this side of the table now, Azzy Wazzy? Okay. A chemist takes 2.5 liters of 5.6 moles NaOH with enough water to make 10.0 liters of what molarity? Okay, so again, so you just take, here's our equation, molarity 1, volume 1 equals molarity 2, volume 2, and you just plug them in. It's that simple. So 5.6 times 2.5 equals M times 10. We're going to divide this side by 10. So 5.6, whoops, I'm going to try to have the calculator so you can see it. So 5.6 times 2.5 divided by 10 is 1.4. So equals 1.4 moles. Perfect. That's exactly what this has. Amazing. You got it right. Okay. One way to make sodium sulfate. Okay. So, nope, that's Mom's. You want to help? Are you going to help me wipe? There, help my mama wipe. One way to make sodium sulfate is through reductions of sulfuric acid with sodium hydroxide. How many grams of sodium sulfate can be produced if 500 milliliters at 1.6 moles is reacted with excess of sulfuric acid? We're starting to get into very classic. Okay, Azzy, you're going to have to sit down. We're doing good until we're not. That's Mama's. You can have your own periodic table when you're in high school. Here you go. Do you want to write on this one? How about this Minnie Mouse? There. Okay. Okay, so one way to make sodium sulfate is through a reaction of sulfuric acid. So now the first thing you need to do is write out your chemical equation. H2SO4 plus sodium hydroxide yields. So you'll have to figure that out. And we know that, and underneath that, go ahead and put what you're using. How many grams of sodium sulfate? So obviously sodium sulfate is going to be produced. NaSO4. Now we know this is a plus 2 because this is a 2 and that's a plus 1. So they're going to have 2 here. 2 here to make sure we have 2 over there. And that should just lead to H2O. Perfect. So there's our balanced chemical equation. So we know that this is how many grams. We're looking for how many grams of sodium sulfate. We're looking at how many grams of that can be produced if we have 500 milliliters of 0.6 sodium hydroxide. So we have 1.6 molarity and we're using 500.0 milliliters. Okay, so we're trying to find this. Pretty classic. So we know that molarity is 1.6 moles over 1 liter. Now, and 1 liter is 1,000 milliliters, and we have 500 milliliters that we're working with in this problem of NaCl. So that's all we have to do is 1.6 moles. It's probably really hard because she's shaking the table. Times 500 milliliters. Oh, we better do 1.6. She did not nap. She's a lot of fun. 1,000 times 500 equals 0.8. So that is our, so here's our liters, our milliliters, and so that gives us our moles. Yes. Moles for that. Yes. Okay, so we know that for every, so 0.8 moles of NaOH. Why don't you go see your daddy downstairs? What is he doing? There's 2 NaOH for every 1 Na2SO4. So then let's see. So we're just going to divide that by 2, that 0.8, which is 0.4. So that's our moles. Na2SO4. Is there Bia? So now we have 0.4 mole NaSO4. So if we have this many moles, we know that 1 mole NaSO4 is what? So we just got to find our atomic mass units of these. So sodium is 22.99. There's 2 of those. So 32.06 and 416. So let's just 22.99 times 2 plus 32.06.06. And then we're going to take 16 times 4 plus our answer. 142.04. So that is what we need to put here. 142.04. 142.04. So our atomic mass units in grams, NaSO4, is that many moles. And so from there, you should be able to get your grams, which is 56.816. 56.816 grams NaSO4. And of course, we need to look at, right here's our molarity, so we only get to use 2 of those, so it should be 57 grams of NaSO4. Let's see how we did. If not, you get to see how, oh, look at that. I was like, we're going to see how we get to rethink those, which is really hard when you have a toddler shaking the table and talking to you and stealing your phone and throwing a fit. That'll be your problem. So, a recap. Always write down your chemical equation, balance it, write down what the molarity in milliliters of what they're giving you, and write down the question mark of what they want, whether it's grams or moles. Because if it's grams, you have to take this extra step to move that moles into grams. This is step 1 of the classic stoichiometry problem. So first you got to find your molarity. From your molarity, you got to find out how many moles are being produced with what you've been given of your volumes. So your moles, we know that molarity equals moles over liters. We got to change that liters into milliliters and multiply it by how many milliliters we have. There we have it. Usually we kind of start by putting whatever we have over 1 This time we can't really do that, I guess. I mean, unless you started here, it's probably all the same thing. We're given 500 milliliters. We need to change it into liters so we can put them over there. I think it'd probably work the same. If you did it that way, that would work. I mean, it's the same thing. And we're given this many milliliters, we gotta change it by moles. And I may have done it that way at one point in time, probably on when I did the work the first time. But it works the same way. You could do this. You could start here with, if you always start with what you're given and put it over 1, and then use your molarity, did your conversion factor, and then use your molarity, you should still get 0.8 moles. You take that answer, the moles of what you're given, and you figure out in your balanced chemical equation how to compare those to what we know and what we're trying to find, the moles of which, to get the moles of the equation of what you're trying to find. Then you take your, if we need to find grams, we need to take our atomic mass units, knowing that that is our 1 gram, the grams of that, the atomic mass units in grams is equal to 1 mole to get our grams. Okay, that was the recap. So, I think that was our last one. Okay, good deal. All right, so yeah, classic stoichiometry right there. And it's just a series of steps. Just step your way through it. We will do our example problems next.